Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where today we are talking about applications of proportions. Alright, so we are talking about word problems here. I like to call them applications because honestly that's what we're doing. We are applying our math knowledge to life, because that's where math kind of lives. It lives in life. It doesn't live on a worksheet someplace. Alright, so as a reminder, proportions simply means that we have a fraction that is equal to a fraction, or a ratio that is equal to a ratio. That's what a proportion is going to be. So we have to have two of them. We have to have an equal sign between them. And this is going to be the basic foundation for our setup today. I want to run you through two examples. And the first one has to do with a very delightful, do you happen to know what that shape is, by the way? That is a trapezoid, a very delightful trapezoid. And they're named by their corners. So notice this trapezoid has an A, B, C, D, and I just went around in a circle like that, A, B, C, D. And then P, Q, R, S. Again, same circle, P, Q, R, S. What does this mean? That A and P line up with each other, and B and Q line up with each other, and so on and so forth. Are these two shapes the same? Are they identical? Are they congruent? No, they're not. But they are very similar. Ooh, the use of the word similar is very specific there. This little wavy line thing means similar. Alright, so I am being told, similar I can spell, that these shapes are similar. What does that mean? Well, that means two things. One, which isn't going to matter a lot to us, but one, it means that all of their angles are the same. Great. The thing is, I'm not really working with angles at the moment, so it doesn't really matter to me that all their angles are the same. But here's the second piece to that. It also means that the sides are, wait for it, proportional. Proportional. Okay? So by seeing that little wavy line, I'm like, hey, I know that I can use proportions here, because it means that my side lengths are proportional. Which means I'm looking for a couple of fractions. And I'm looking for things that actually match up from one shape to the next. So if I'm looking at this, I see the 12 here on the left side and the 18 on the left side, and they're both on the short vertical side. So I'm thinking that those two are kind of a pair. So what I'm going to do is I'm going to say, I'm going to take the, I'm going to write it this way. The side from the smaller trapezoid, I'm going to stack it on top of the side from the larger trapezoid. Why am I taking a moment to write this out? Because it matters, all right? How you stack these numbers is important, and you have to be consistent. You can do the larger over the smaller. Ooh, maybe I should put smaller. There we go. I can do larger over smaller as long as both fractions are set up that way. I'm going to do smaller over larger, and I just want to make sure that both fractions are set up that way. So smaller, 12. Larger, 18. There we go. All right, I have something that I'm trying to find. There is my x. I'd like to know the length of this side. Well, this side comes off of the larger trapezoid. So when I go to set up my second fraction, I want the x on the bottom because 18 came from the larger trapezoid, and x, my missing side, is on the larger trapezoid. Well, what matches up with the x in the other trapezoid? This is on the right side, that's x. On the right side over here we have got 20. So x matches up with 20 on the smaller trapezoid. Ladies and gentlemen, put your equal sign in the middle. This fraction should equal this fraction. Whatever shall I do? Oh no. Have we considered, I don't know, fraction equals fraction. I want a different color here. Have we considered cross multiplying today? Because maybe we should do that. All right? Cross multiplying. If things are proportional, if I've got two fractions equal to each other, that means when I multiply this direction, it will equal the exact same thing as if I multiply this direction right here. The exact same thing. Which means 18 times 20, that is 360. Feel free to grab your calculator if you're not sure on that one. I don't blame you. Equals, the same thing, equals, same thing, other direction, 12 times x. Oh, and now I have a happy little equation that I can solve. I can do this. I want to get x by itself. There's a 12 next to it. It's being multiplied. I want to undo that. Dividing by 12, same thing on both sides. Boom, there's my x by itself. And 360 divided by 12 is 30. Ladies and gents, that is my missing measurement, is 30 for this tall side here. All right, so that is one application of proportions. And the other example I want to show you today also deals with shapes, but maybe less obvious shapes. All right, so round 2. Congratulations, you are 5 feet tall. Did you know that? Your shadow at the moment is 7 feet long. At the same time, a tree next to you has a shadow that is 20 feet long. How tall is the tree? Now, this may seem like a little bit of a silly question. Who cares how tall the tree is? Can't I just measure it? Well, maybe it's too tall. Maybe my tape measure doesn't quite reach. And maybe I'm trying to take this tree down and I'd like to just topple it over, and I'd like to know how long it is so that it doesn't hit my house or my car. So maybe there's a reason I might actually use this. You never know. All right, so let's think about this. There is you. Congratulations, you are 5 feet tall. And there is you. That looks just like you. Can you tell that I've never had an art class? You are 5 feet tall, and at the moment, your shadow is right here. Boom. Your shadow is 7 feet long. Do you see the shape there? There's kind of a shape there. It's like a triangle. There's you. There's 7. There we go. All right. Do I need to actually have a triangle for sure? Well, believe it or not, it is kind of useful, but you know, okay. So, tree. You're standing next to a tree. Here's my tree. Now, again, I've never actually had an art class, so I need you to not tell the art teacher, because I've been told that you were not supposed to draw broccoli trees. And broccoli trees are the only kind of trees I know how to draw, so don't tell the art teacher, okay? That is the tree. The tree has a shadow that is longer than your shadow. It is 20 feet long, and the question becomes then, how tall is the tree? I don't know how tall the tree is, but there's my other triangle. And again, this idea of having shapes that are similar to each other, these triangles are going to be similar because of the angle of the sun, believe it or not. So I just need to set up a couple of proportions again. I need something to be equal to something. So let's think about how this might work. Here I did smaller over larger. Here I might do me over tree. That could work, right? So, me. I am 5 feet tall. How tall is the tree? I don't know. X. Okay. Me, my shadow specifically, is 7 feet long. The tree has a shadow that is 20 feet long. So notice I did me, my height, and my shadow over the tree, its height and its shadow. Equals, and solve. Take a moment. Pause. Solve. Get back to me. Tell me what you get. Ready? Pause. Did you figure it out? How does this work again? If these are truly proportional, which the equal sign says they are, when I multiply across this way, I should get the exact same thing as when I multiply across this way. And so this is how I'm going to set up my equation. Again, these two things have to be equal to each other. So 5 times 20 is 100, and that has to equal 7 times x, 7x. It doesn't come out nice and neat. Well, that's okay. When was the last time you met a tree that was exactly a certain number of feet tall and no inches? That's silly. Dividing by 7, again trying to undo this, get the x by itself. I need to borrow my calculator because 100 divided by 7 off the top of my head, not sitting so pretty at the moment. Ooh, there we go. So borrowing the calculator, I've got 14.28. So the tree is a little bit taller than 14 feet, definitely not quite 15 feet. There we go. That is how tall the tree is. Okay, so applications of proportions, ladies and gents, this is it. Look for shapes that are similar, set up your proportions consistently, cross multiply, and solve. All right, have some fun with that.